This problem is just a spin off of an order of operations problem. What the problem is asking you to do is to evaluate, which again it's worth noting what evaluate means. Evaluate is different than simplify or solve. Simplify is implying that you just want to get your answer in simplest expressions. Solve usually involves an equation where you're actually solving for a variable. Evaluate is when you're taking a variable expression and actually plugging numbers into the variable expression and then simplifying to get a single answer. So again, this problem asks you to plug all of these numbers into this expression and then simplify using order of operations. The first thing I always tell my students to do is don't do too much. The first step, even before anything else of order of operations is involved, is to simply plug the numbers in correctly. So as you can see here, I'm gonna replace all of these variables in this expression with the correct variables that are listed over here. I'm not going to simplify it. I'm not going to change it a single thing about the problem. I'm simply going to plug in a number for the variable. So as you can see, our first part of this problem, it has z squared. Well, z is equal to 5 in this case, so I'm going to write that as 5 squared. 5 squared. Minus y squared, well, y is 2, so that will be 2 squared. And then that will be all over x times z, so that will be 3 times 5 minus 2 times y, well, y is 2, and then parentheses z, which is 5, minus x, minus 3. Okay, once you plug the, excuse me for that 3 there, once you plug these numbers in, now you can see that this is really an order of operations problem. Again, this big division bar separates these into two kind of groups, a top group in the numerator and a bottom group in the denominator, which you can work on them separately. On the top, our first step is to use the exponents rather than subtraction. And you can actually do both exponents at the same time because they're not going to affect each other. You have to do both exponents before you take the subtraction sign anyway. So if you want to simplify 5 squared, you get 25 minus 2 squared, which would just be 4. All right. On the bottom, there's a lot going on the bottom, and I'm not going to try to do too much here. Again, order of operations tells us to do grouping symbols first, so that's what I'm going to do first here, is to simplify what's inside these grouping symbols. I'm not going to change anything else. I'll still have 3 times 5 minus 2 times 2, and then again times 2, because 5 minus 3 will equal that last 2. Okay, on top we can simplify to get one number. 25 minus 4 is 21. On the bottom, kind of the same concept as what we were doing up here earlier. Multiplication comes before subtraction. So both of these multiplications, or all of them, I should say, all three of them, should be done before the subtraction. So you could actually do them at the same time because they won't affect each other until you take the subtraction. So 3 times 5, you can see it will be 15. And then minus 2 times 2 times 2, well, that will be 8. All right, again, on top, we still have 21. That's already simplified. On the bottom, we have 15 minus 8. Well, that will be 7. And then our final answer, once we finally have one number on top and one number on bottom, we can combine and actually take that division bar into play now. 21 divided by 7 will be equal to 3. And again, what this problem means is that this expression will be equal to 3 if you correctly plug all of these numbers into the correct variable positions.